Welcome to my video on integrating using partial fractions. So you can see this integral here is a fraction with the numerator of order 1 where the denominator is order 2. If they were equal order, or if the numerator had a higher order, then you'd want to do long division before you start. This one doesn't have that, so in this case we start right with the partial fractions. We'll start off by rewriting the numerator over the factored denominator. So you make sure I have the right tool here. So 2x plus 16 over x plus 3 times x minus 2. All right, that would be equal to a over x plus 3 plus b over x minus 2. Seems like my handwriting is extra sloppy today. So now what we need to do is multiply through by the common denominator. You'd get 2x plus 16 equals a times x minus 2 plus b times x plus 3. And then we can use a little trick to let x equal 2. That will make the a term go away, and we'll end up with 2 times 2 plus 16 equals 5b. Okay, you add those together, that's 20. So 20 equals 5b, or b equals 4. And then we can let x equal -3. And in that case, you're going to get -6 plus 16 equals a times -3 minus 2, or -5. All right, you can see that's 10. 10 divided by -5 is -2. So a equals -2. All right, so then we'll change colors here so I can mark that up. That means this thing would be equal to -2 there and 4 here. Now I've had enough experience doing these. I recognize that when I'm changing this into the integral, I want to put the negative term second. So I'm going to do that as I rewrite it. So this integral then, I'll move it down here so I have some room to work. We'll break it up into two separate integrals. I'm going to write the positive one first. So it's going to be the integral of 4 over x minus 2 dx plus the integral of -2 over x plus 3 dx. All right, you can integrate each of those separately, and that ends up being ln of absolute value of x minus 2. And I forgot the 4, so the 4 goes out in front. And then -2 ln of absolute value of x plus 3. You can see if you're trying to use u substitution here, u would be equal to, let's go ahead and show that. So u would be equal to x plus 3. So du would be equal to 1 dx, taking the differential of both sides. And so we just need a 1 there, which is easy to throw in there. That -2 then can go on the outside right here. And you're just integrating 1 over x plus 3. So you can see that's ln of absolute value of x plus 3. Go back to my normal color here. So then I can take this, actually I do need a different color. That 4 can become an exponent here using our log rules. And same with that 2. We'll leave the negative sign alone. So the 4 and 2 are gone out in front, and now they're exponents. All right, now also using the log rules, we know we can do the log of, the difference of two logs can be written as the log of a quotient. So we're going to write that as ln of x minus 2 to the 4th over ln of x plus 3 squared, and then that's plus c. Now you may notice that I got rid of the absolute values, and the reason for that is those are odd powers, so of course x minus 2 raised to the fourth is always going to be positive, so that ends up in letting us get rid of the absolute values. Same thing happens on the squared term right here, that x plus 3 squared would always be positive, so we can ditch the absolute values there also. So there you go. There's our answer. Hope you enjoyed the video. Thanks so much for listening.